Hey everybody, what's going on? It's your boy Algebra coming to you live and direct from the studio, aka my living room, aka Erica's not home, but if she gets here before I finish recording this thing, I'm probably going to be a little bit awkward in front of her. 8:57 p.m. I apologize for being about 3 hours late. Right now I need to start talking about this thing really fast. We're going to be doing everything that we were supposed to get done during class today, which is involving rationalizing complex denominators. I know some of you are taking notes right now along with the video. Some of you are just going to read the PDF and not actually listen to the words that I'm saying to you right now. I would strongly suggest otherwise. But if you choose to do that, hey, you make your own bed, you lie in it, and hopefully you sleep well. Complex denominators, though. A complex denominator is a denominator whose expression has more than one term. Check out the simple diagram below. 3 over x is simple, but 3 over x minus 9 is complex. So because there's that minus in the bottom, because there could be a plus in the bottom, because there's more than one term down there, it could be a binomial, it could be a trinomial, it could be a tetranomial. But as long as there's more than one, we call it complex. We're going to be using this thing called a conjugate to get rid of those. If I have x minus 9, the conjugate is x plus 9. It's the other half of a difference of squares. Two things before we go any farther. One, a conjugate is not the same thing as a concubine, Jacob Lacey. That's gross. You're a nasty dude for thinking that way. Secondly, when we talk about a conjugate, we're talking about square roots only. I'm not going to give you cube roots in these. I'm not going to give you seventh roots. We're going to be doing things that kind of follow the same pattern as the difference of squares. I could potentially give you a difference of cubes down the road, but if you don't remember the things that we talked about from the beginning of the school year, that's not going to work. And I know 95% of you don't remember those. Having said that, having given you enough time to copy this down, I'm going to move straight into the first example. I'm hoping that we can get through 4 examples before my 15-minute window is up. This is also the 4th time I'm recording this. Therefore, there's going to be a lot more examples on the PDF version than you get during the actual video. Keep that in mind. Going on to the first example. So I said first example, but I'm actually going to do 2 of them, one at a time, of course. 6 over the square root of 5 is the first one. The understanding is that because this is a simple denominator, all I need to do is finish the group. I have 1 5 right now, but because there's a porch number that's imaginary, which would be a 2, I need another 5. Remember, we need to find a pair so that we can get rid of the radical. That pair comes up by using the square root of 5 on top and on bottom. If you remember, 1 over 1, 2 over 2, 3 over 3 are all actually equal to 1. I'm not changing the equation. I'm just making it look a little bit different. The square root of 25 now on the bottom. 6 radical 5 on the top. We did this for a reason. Square root of 25 is 5. Final answer for this one is square root 5 with the 6 on top. 6 square root 5, that is, over 5. Done. Now the next problem, a little bit more complicated. 2 different ways to do it. I'm going to show you both ways again. Joe Crossan in the back row said, I see 1 4. I need 2 more. Bars. So he does this. That is not the only way to do this problem. In the front row yesterday, Julia said, can't I just make that 2 squared? That way I have smaller numbers to deal with. Absolutely. You are more than welcome to make your problem look like this instead. You only need 1 2 for this situation. Small numbers are most people's friends. whichever way you chose to apply your extra radical so that you can rationalize the denominator, it works out the same way in the end of the problem. On top, 7 times the cube root of 16 all over, shows these numbers for a reason again, 4. In the bottom equation, 7 times the cube root of 2 all over 2. That is completely done. No simplification needed. But on top, you need to break down the 16. 7 times the cube root of 2 to the 4th power. That means there are 4 2's. I'm going to take a group of 3 on the outside. My final answer for this part would look like this. Oh wait, I can reduce it. Same final answer. 7 times the cube root of 2 over 2. Either way that you choose to simplify, the complex or the simple denominator works. I'm going to give you a complex denominator now. And the complex denominator, we're going to change the process a little bit. We're going to use this thing called the conjugate. I just started talking about it a second ago. So I'm going to pop up a couple of rules talking about how you know which method to use, whether you can be done with the problem, whether you need to finish the group versus how you should use the conjugate, and then we'll actually go ahead and do the example. Alright, so at the very top of the screen right now you see 3 basic rules. If there's no radicals in the denominator, don't worry about it. You're done. If there's one term with 1 radical in the bottom, you need to finish that group. If there's 2 terms with radicals, I don't care if it's the first term, the second term, both terms, we're going to need to use the conjugate to get rid of those. Now, I mentioned it earlier as far as what the conjugate is. It's when I take the plus in the middle of here and change it to a minus. But why does it work is just like a simple difference of squares problem. X plus 2 times x minus 2 becomes x squared minus 4. We're going to use the plus and the minus to cancel out that middle section of the distributive property. And we're also going to be able to cancel out the radical in doing that. So applying the conjugate is going to look like a complicated multiplication problem, but trust me, it's going to work out. We're using 5 minus the square root of 3 on top and on bottom. I don't think anybody has any issues multiplying the top. 55 minus 11 radical 3. But the bottom, not that familiar with a binomial with a radical that I'm multiplying times another binomial with a radical. So let me write it out for you. 5 plus the radical 3, 5 minus the radical 3. I'm going to FOIL it. On the top part of this FOIL, going here and here, I end up with a 25 minus 5 radical 3. On the bottom of it, going like this, I get a positive 5 radical 3 and a minus radical 9. Notice again, the reason why we chose this in the middle, using the conjugate, is going to make it so this middle section is gone. That cancels each other out. And again, notice the reason why we chose this is because now I have 25, and I know the square root of 9. That's 3. The bottom is really just 22. I'm going to go one more step right now because I noticed that it's 55, 11, and 22. Simplify it down. Final answer for this problem is 5 minus the square root of 3 over 2. It will not always work out like that. I picked a great one to start with. I'm going to pause my screen again for a second, And then I'm going to give you another example. We're going to have about 5 minutes to work through the last example for the day. It's going to be a lot harder than this one, but you'll also be able to look through all the work from the 4 videos that I made before this, which got messed up in the process. My microphone messed up. Don't even worry about how all that stuff happened on the actual PDF of this transcribed session. All right. Last example of the video. There'll be more to be seen on the actual PDF again, but I need to go ahead and speed up the process. Notice the top has 2 terms, the bottom has 2 terms. I don't care about the fact that the top has 2 terms, though. It's fine the way it is. I only care about getting those radicals out of the bottom. Using the conjugate, not of the top, of the bottom, I can get rid of it. So, process says I need to use a distributive property. I'm going to change up the way I distribute this time. A couple of people in the class probably use the box method. I'm going to show them using the box method. Those of you who FOIL or use some other type of multiplication, just look at the inside of the boxes. The inside of the boxes should match the 4 terms that you get when you do your multiplication. This is the bottom in the blue box. And in the red box, I'm going to be doing the top. Notice I included my negatives because I don't want to lose any positives and negatives in the process. 2 boxes. That means I'm doing 2 different distributive properties. Here comes the first one. 1 times 1 is 1. 2 radical 5. Negative 2 radical 5. Did that for a reason. Goodbye. See you later. On the outside, one more time, negative 4 times the radical 25. Radical 25, that sounds like 5 to me. 1 minus 4 times 5, 1 minus 20, negative 19. That's the bottom. Now looking at the top, a little bit more complicated, but I don't really care about the final result on top. I'm just worried about getting the radical out of the bottom. Here's what I get from my multiplication. And the last box over here is going to be a positive 2 radical 15. All of those are different. That means I can't combine them. That means all of this stuff is going to stay on the top. And that's fine. Your answers for this chapter are going to look like poo-poo. Ew. But that does not mean that they're wrong. Final answer for this problem. It is completely done now. 4 minus the square root of 3 minus 8 radical 5 plus 2 radical 15 all on top. And on the bottom, negative 19. No more radicals on the bottom, so this is an acceptable answer. This is called rationalizing a complex denominator. So a couple of questions are going to come up. 1. Why is this so hard? I would remind you a couple things. You know how to multiply binomials, FOIL method. You know how to multiply radicals. You know that if you are adding or subtracting radicals, they have to have the same porch number and they have to have the same inside decor, meaning the number is and the letters all inside of the radical house itself. You can do each individual part of these problems. It gets confusing and it gets intimidating more so than anything when I put them all together at once. Trust the process, which is simplify your equation, your expression, as much as you possibly can, and then stop. If you broke it down and it ended up with a radical, is the radical in the top or in the bottom? If it's in the top, so what? If it's in the bottom, now we ask ourselves, is there a complex denominator or is it simple? If it's simple, finish the group. If it's complex, use the conjugate. Either way, I trust you guys. You're going to be fine. Trust me when I tell you that. This has been your boy, Algebra, and I'll see y'all either in class tomorrow or next week. Peace.